Hello students, welcome back to the new session of number systems. Students, in this session we are going to solve the problems using operation and properties of real numbers. In the previous sessions I had explained clearly about these properties and operations of real numbers. First we can look out the properties of rational and irrational numbers, that is the addition of an irrational number and a rational number gives an irrational number. The difference of an rational number and an irrational number gives an irrational number. Multiplying any rational number with any non-zero rational number results in an irrational number. About the operation on irrational numbers, the sum of two irrational numbers need not to be irrational, difference of two irrational numbers need not to be irrational, product of two irrational numbers need not to be irrational, and quotient of two irrational numbers may or may not be an irrational. For these conditions, please go through all these conditions thoroughly and clearly and apply it in solving the problems. Let us start the exercise 1.5. First question, classify the following numbers as rational or irrational. The first subdivision, 2 minus root 5. Solution for this question is an irrational number, that is 2 minus root 5 is an irrational number. Since 2 is a rational number and root 5 is an irrational number, therefore we can conclude that 2 minus root 5 is an irrational number. Already we know that the difference of a rational number and an irrational number is always an irrational number. Students, let's go to second question, 3 plus square root of 23 minus square root of 23. Solution. Students, first please check whether it is possible to simplify the question or not. Here we can simplify plus square root of 23 and minus square root of 23. While simplifying this, we got the result as 3, which is a rational number. Hence, we can conclude that 3 plus square root of 23 minus square root of 23 is a rational number. Let's move to third question. 2 root 7 divided by 3 root 7. In this question also, we can simplify that root 7 and root 7. While simplifying the two numbers, we got the result as 2 by 3, which is a rational number. Hence, we can conclude that 2 root 7 divided by 3 root 7 forms a rational number. Now we can start fourth question, 1 by root 2. Solution. 1 by root 2 is an irrational number since 1 is a rational number and root 2 is an irrational number. Therefore, we can conclude that 1 by root 2 is an irrational number since the quotient of non-zero rational number with an irrational number is irrational. And students, please try that fifth question as a home assignment. Now we can start second question in the exercise 1.5. Simplify each of the following expressions. First one, 3 plus root 3 into 2 plus root 2. Multiply these two numbers. While multiplying, we are getting the result as 3 into 2 plus root 2 plus root 3 into 2 plus root 2, which is equal to 6 plus 3 root 2 plus 2 root 3 plus root 6. Here we can't simplify this answer, so we can write the answer as 3 plus root 3 into 2 plus root 2, which is equal to 6 plus 3 root 2 plus 2 root 3 plus root 6. Now we can go to second question, 3 plus root 3 into 3 minus root 3. It is in the form of a plus b into a minus b. Hence we can apply that identity to find the answer of this question. So consider a as 3 and b as root 3. Hence we can write the question as 3 plus root 3 into 3 minus root 3, which is equal to 3 square minus root 3 the whole square. While simplifying we are getting the answer as 9 minus 3, which is equal to 6. Hence we can say that 3 plus root 3 into 3 minus root 3, which is equal to 6. Now we can go for third one, root 5 plus root 2 the whole square. This also it's the form of an algebraic identity, a plus b the whole square, which gives the result as a plus b the whole square, which is equal to a square plus 2ab plus b square. Consider a as root 5 and b as root 5. Apply that identity to find out the answer. So root 5 plus root 2 the whole square gives the result as root 5 the whole square plus 2 into root 5 into root 2 plus root 2 the whole square, which is equal to 5 plus 2 root 10 plus 2, which is equal to 7 plus 2 root 10. Hence we can say that root 5 plus root 2 the whole square, which is equal to 7 plus 2 root 10. Now we can go to the last question, root 5 minus root 2 into root 5 plus root 2. This is also in the form of a plus b into a minus b. So we can apply the algebraic identity a plus b into a minus b, which is equal to a square minus b square. Hence we can say that root 5 minus root 2 into root 5 plus root 2, which is equal to root 5 the whole square minus root 2 the whole square is equal to 5 minus 2 is equal to 3. Hence we can conclude that root 5 minus root 2 into root 5 plus root 2, which is equal to 3. Students, now we can solve the question number 3 in the exercise 1.5. Recall, pi is defined as the ratio of the circumference AC of a circle to its diameter CD, that is pi is equal to circumference by diameter, which is equal to C by D. This seems to contradict the fact that it is irrational. How will you resolve this contradiction? Solution for this question, actually C by D, that is circumference by diameter, which gives the result as 22 by 7, which is an approximate value of pi. I'll give you the reason for this. That is, we know that when we measure the length of a line or a figure by using a scale or any device, we do not get an exact measurement. In fact, we get an approximate rational value. So we are not able to realize that either circumference c or diameter d of a circle is irrational. Therefore, we can conclude that as such there is not any contradiction regarding the value of pi, and we realize that the value of pi is irrational. Students, now we can start question number 4 in the exercise 1.5. Represent square root of 9.3 on the number line. For that, I had given the construction as well as the steps of construction. See the steps of construction and start constructing it. First step, draw a line segment 9.3 and name it as AB and extend B to C for 1 unit. Then the value of AC will become 10.3. To find out the midpoint of O, construct a perpendicular bisector of AC and name the midpoint as O. And with O as center and OA as radius, draw a semicircle. And draw a perpendicular line on B which intersects the semicircle at D, then join OD, then it will become, value of OD become 10.3 by 2, since we know that OA which is equal to OC which is equal to OD. And the sixth step, we got the value of BD as square root of 9.3. Since the figure represents a right angle triangle, the name of the right angle triangle is OBD. OD represents the hypotenuse and BD as well as OB are legs of the right angle triangle. So we can apply the Pythagoras theorem to find out the value of BD. Hence we got BD which is equal to square root of 9.3. I will explain, I will tell you how to find out this calculation using the justification method. Now you can take B as a center and BD as a radius. That is, BD is equal to square root of 9.3 as a radius. Draw an arc which intersects the line segment at E. Then the value of BE will become square root of 9.3. Hence we can conclude that BD which is equal to BE which is equal to square root of 9.3. At last we represented the square root of 9.3 on the number line. Now we can go for justification. While applying the Pythagoras theorem, you can write OD square which is equal to OB square plus BD square. But we need to find out the value for BD. Hence, we can write BD which is equal to square root of OD square minus OB square. We know that OD is equal to OC is equal to OA which is equal to 10.3 by 2, as well as OB which is equal to AB minus OA. Just see the figure, you can get it, which is equal to 9.3 minus 10.3 by 2 gives the result as 8.3 by 2. While substituting the value of 10.3 by 2 and 8.3 by 2, the calculation, while simplifying, we are getting the result as BD which is equal to square root of 37.2 divided by 4. This results BD which is equal to square root of 9.3 which is equal to BE. In this way we have to represent the square root of 9.3 on the number line. Students, we came to an end of this session. In this session, you all learned how to classify the real numbers, simplify the real numbers, and to represent the real numbers on the number line. Thank you.